In this video, we are going to talk about integrating factors found by inspection. So you simply have to inspect your differential equations, whether these four exact differentials occurs in your differential equation. And then ultimately, you will solve the differential equation by simplifying into these exact differentials. Okay, so take a look. These are very basic differentials that you have already known since your calculus. So let's go to example problems. Problem number 1. Quantity x cubed y cubed plus 1 differential x or dx plus x to the fourth y squared dy is equal to 0. So the first thing that we are going to do here is we will distribute dx or dy to simplify, and then observe that your first term and third term has common factors, and the common factor for those two would be x cubed and y squared. So if we will factor out from the first term and the first and the third term, we will obtain y dx plus x dy, and then we have plus dx is equal to 0. Now, this form, as you can see by observation, is the differential of x times y. So what will we do in order to simplify the equation in order for us to solve? Observe that if I will multiply 1 over x, this will now become xy squared differential of xy plus dx over x is equal to 0. Now this can now be integrated. The first term being a power formula for integration, we have u raised to n du. So this will be xy cubed over 3 plus ln x is equal to c. So finally, just to simplify, we simply multiply 3. So we will have x cubed y cubed plus 3 ln x is equal to c. And that would be our final answer. So problem number 2, we have y times a quantity x cubed minus y to the fifth plus quantity dx minus x times a quantity x cubed plus y to the fifth close quantity dy. So similar to what we did in the first problem is we first distributed. So we have x cubed y dx minus y to the sixth dx minus x to the fourth dy minus xy to the fifth dy. So next is we will observe what can we factor from the terms that we have simplified into. So notice that the first and third term we can factor out x cubed. If we factor out x cubed, then the first and third term would have y dx minus x dy. From the second and the fourth term, we can factor out negative y to the fifth. So if we factor that out, we'll have y dx plus x dy. Now it's clearly seen here that this is already the differential of xy, while this one would lack y squared, no? Or 1 over y squared for it to become the differential of x over y. So we will borrow from our y to the fifth. So we'll have, if we multiply 1 over y squared, then this will now become x cubed y dx minus x dy all over y squared minus y cubed, then y dx plus x dy is equal to 0. Okay? Now, this one is already the differential of your x over y. So, what we need here is again to multiply. If we will multiply again 1 over y cubed, then this term right here would become x over y raised to 3 and then multiplied by the differential of x over y, therefore forming again another power formula for integration. So minus the differential of this one would become the differential of xy. So if we integrate, this will now become xy to the 4 over 4 minus xy is equal to c. Now to simplify that, we can multiply 4 and we will now arrive at our final answer, which is x to the 4th over y to the 4th minus 4xy is equal to c. So that is our final answer. Okay, let's go to problem number 3. So we have quantity 1 plus y tangent of xy close quantity dx plus x tangent of xy dy. So first, distribute. We have dx plus y tangent of xy dx plus x tangent of xy dy is equal to 0. Now the first and the third term, we can factor out tangent xy, and we would have quantity y dx plus x dy inside the quantity. So this will be dx plus. Now, this one can be simplified as the differential of xy. So we can now integrate and simply apply just the integral of tangent u, and we know that the integral of tangent u is equal to secant u. So we'll have x plus the ln of secant xy is equal to c. And that is our final answer. So as you can see, class, from the 3 problems that we already had, we just simply do the thing all over and over again, wherein we first distribute, and then after distributing, we will look for a pattern. So that's very important in mathematics, looking for a pattern. Now let's go to problem number 4. This would be the last problem in this video. So we have y times a quantity, x squared plus y squared minus 1 close quantity dx plus x times a quantity, x squared plus y squared plus 1 close quantity dy is equal to 0. So let's distribute and simplify. We have x squared y dx plus y cubed dx minus y dx, and then we have x cubed dy plus xy squared dy plus x dy is equal to 0. Now, similar to what we did, we look for a pattern that would occur. So, if you notice, your first and your third term, you can factor out here y, but that would lead you to nothing. No? So, you look for another partner. You have x squared y here, and you have x cubed here. If I factor x squared, then that would mean something, right? Because if I factor out x squared from the first and the third term, I will have y dx plus x dy. So that is, let's put a check. And then let's observe the second term, y cubed dx, and then the fifth term. So if I will factor out y squared, then I would have y dx plus x dy again. So that would leave us with the last term here, which is plus x dy minus y dx is equal to 0. So here, because we have the differential of xy from both of this, we could factor that out. So we have y dx plus x dy times a quantity x squared plus y squared. And then we have x dy minus y dx is equal to 0. Now, if I will divide or multiply 1 over x squared plus y squared, then that would leave my differential equation as y dx plus x dy plus x dy minus y dx over x squared plus y squared. And then finally, it's clear to see that this is the differential of xy, and this would be the differential of your arctangent y over x. So that is equal to 0. So this would be very easy now to integrate. This is simply xy plus the arctangent of y over x is equal to c. And that would be our final answer. So as you can see, class, you just have to recap this up. You simply have to observe very carefully and simplify to these 4 exact differentials that can occur frequently in your problems. So the key here is to observe and to look for a pattern. Thank you for watching.